Okay, we're moving into part 2 of lesson 2.2. And to start, we have some more definitions. Equivalent statements. When two statements are both true or both false, they are called equivalent statements. Equivalent means they're the same, they're equal, they're interchangeable, etc. Conditional statements. A conditional statement and its contrapositive are either both true or both false. A conditional statement and its contrapositive are either both true or both false. The last example we did where we were doing all of the if-then statements and changing them all around, if you remember, the first one and the last one would always be both true or both false, and the middle ones would be both true or both false. Here we say the converse and its inverse are either both true or both false. Okay, that shows true for the stuff that we just did. Pairs of statements like these are called equivalent statements. Definitions. You can write a definition as a conditional statement in if-then form or as its converse. I know there's a lot of words here that are new and confusing, and that's why that note card might make a really good idea, or you need to write them down in your notes. I expect everyone's notes to be pretty long, this section, because there's just a lot to learn. Both the conditional statements and its converse are true. Example, perpendicular lines, a definition. If two lines intersect to form a right angle, then they're perpendicular lines. The converse, if two lines are perpendicular lines, then they intersect to form a right angle. Okay? Extra info. Line L is perpendicular to line M. That's an M. Make these actual lines with arrows. Can be written as L perpendicular to M. That's a little easier to see. All right, let's use these definitions. Decide whether each statement about the diagram is true. Explain your answer using the definitions you've learned. Okay, line AC is perpendicular to line BD. That is a true statement. Okay, we know that because the right angle symbol indicates the lines cross to form a right angle. Therefore, perpendicular. Next question, same diagram. Angle AEB and angle CEB are a linear pair. AEB, CEB are a linear pair. The definition we know about linear pair is they share a side. Okay, there's the side that they're sharing, so that is also true. Okay, linear pair. So they share a side, and the non-common sides form opposite rays. The non-common sides form opposite rays. Oh, for goodness sakes. There's my Minnesotan accent coming out. Opposite rays. Next. Ray EA, and ray EB are opposite rays. EA and EB are opposite rays. That is false. Because points A, E, and B are not collinear. Okay, you try this one. All right, push pause and explain your answer using definitions. Okay, it's true. The reasoning being linear pairs are supplementary. And we know they're linear pairs because non-common sides form opposite rays, therefore they're linear pairs. This is another you try, push pause. This one's false. We don't know the measures of FM, line segment FM, or line segment MH, so we don't know if these are equal or not. Okay, so we don't know if that's the midpoint. Another you try, push pause. True. Those two angles listed are formed by two intersecting lines. Last you try. Go ahead and try it. There you go. Moving on. Biconditional statements. A biconditional statement is a statement that contains the phrase if and only if. It seems so proper and so powerful. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. Any definition we've learned can be written as a biconditional statement. An angle is 90 degrees, an angle is right if and only if it's 90 degrees. Things like that, definitions. Example 4, write the definition of perpendicular lines as a biconditional statement. I think I sort of gave you the answer to that one. Okay. Two lines are perpendicular if and only if they intersect to form a right angle. And like I said, everyone's answers are going to be different. You just have to get the main parts of it. You try. Write the definition of right angle as a biconditional statement. An angle is a right angle if and only if it measures 90 degrees. You try, okay? Push pause, please. That one was a little bit more complicated in my mind. If Mary's in theater class, she will be in the fall play. If Mary is in the fall play, she must be taking theater class. So I went for the beginning and the end. Okay, if Mary's in the theater class, if and only if she'll be in the fall play. Okay, I picked out the important parts and came up with an if and a then. Okay, daily homework quiz. Go ahead and push pause. I'm just going to write the answers down and we'll go over them tomorrow.